Hi, welcome everyone, and good evening and welcome to the data science speaker session. Is my voice clear? Just write a voice and voice is clear in the chat, everyone. Okay, great. So again, welcome to Data Science Speaker Summit. Over the next 3 days, we will be having multiple sessions over multiple topics across data science. So joining us for today's session, we have Mr. Indrajit Rath and Ms. Sushri Rath. Oh, Mr. Indrajit Kar and Sushri Rath. So they are from Siemens Advanta. And hi, both of you. How are you doing?
Doing good. How are you, Hiren?
Yeah, I'm fine as well.
Yeah, I'm better. Thank you.
Yeah, so we are glad to have you both here today. So Mr. Indrajit is a product and AI leader, and Ms. Sushri is a cloud AI key expert at Siemens Advanta India. Their team is responsible for influencing the adoption of data and algorithm-driven decisions for Siemens business. They develop sustainable roadmaps to enable accelerated AI and ML adoption, as well as drive the overall AI technical thought leadership in the organization. Today, the duo will be talking about inventory demand forecasting using advanced analytics. Data science is turning supply chain into strategic. Data science is turning supply chain into a strategic advantage. So, how data science is being implemented in supply chain management, inventory management, the duo will be talking about that today. So, I would like to hand over the session to you both. So you can carry on.
Thank you, Hiren. So thank you everyone for taking out time, and I think after office, most of them, or probably people are still in office and listening to us. I didn't want to bore you guys with bunch of PPTs, but let me tell you what's happening in supply chain. And one of the, probably we'll share one of the use cases. And so she has some code because nowadays everybody wants to see some code, something happening. As and when we speak about AI ML, they want to see something. Ideally you don't really see anything until unless the input data comes in and the output comes in, and probably it will be just bunch of graphs. In having said that, specifically this supply chain, why did I choose this topic, supply chain, is today because see, data science and supply chain are very correlated. It's going on for ages, I would say, that it's not something new. Every business leader that is there and who are performing top in their organization uses data. If anybody is not using data, they will lag, they will fall behind, because until I look into my data, I will not understand how is the business working. I cannot measure, I cannot monitor, I cannot innovate without having data in hand. Now let's understand the supply chain domain. Now, how does this supply chain really works? So let me give you some examples. Let's say a fulfillment company packs up bananas, stores them, and transports them from farm to a grocery. We call it a 3PL. In supply chain, there is something called a PLs. So we call it this as 3PL. A little bit domain, because I always feel that if you do not understand the domain and if you become a data scientist, that it becomes very difficult, because I'll tell you why. There are models, and again I'm talking to models which are related only to domains, can be applied only to this kind of particular kind of domain. Like we in IIoT, we get a lot of physics related. In supply chain, there are a lot of numeric data. In healthcare, a lot of documents that we get. So, and there are particular models, there are particular algorithms that we can apply. So as I was coming back to PLs, that this is also kind of a logistics. See, logistics supply is a crucial part of supply chain. Inventory is a crucial part of supply chain. So warehouse is a crucial part of supply chain. Customer is a crucial part of supply chain. So supply chain is everything. It covers everything. Like, if there is a manufacturing company who produces nuts and bolts, they want to take the nuts and bolts, like the banana example, to the end customer. For here, the end customer probably a factory. Now, if I am a, let's say, company who sells laptops, they want to manufacture a laptop and take it to the end customer. That's supply chain. You're supplying, and supply chain involves demand, advertisement, marketing, uh, data analytics and machine learning and AI, everything is there in this supply chain. Now, so I will just stop at 3PL because I don't know, there are 4PLs, there are 5PLs in that way. Now, as I said, that warehouse is a crucial part of this supply chain. Let us also understand that before even going ahead into the supply chain, what is there for a data scientist? Why do I even need to care about supply chain if I'm not even a supply chain domain? I've already told you. But apart from that, what are the major KPIs which I can predict using data? There's something called, I'll just talk about 5 to 10 of them, and inventory being top in the top. So let me start with cash to cash cycle time. Okay, so cash to cash cycle time represents the average length of a time required to convert something called a cash flow. Okay, starting from the moment you pay for inventory to the time you collect the money. Now you see, I said collect the money. Now there is something called a collections. Collections, credits, that also is part of a supply chain. It's a huge one that I'm talking about. So let me just shift gear and tell you 6 P's of supply chain. The 6 P's are, let's say, procure to pay, make to order or make to stock. Then comes quote, order to cash, third party warehouse or drop shipment fulfillment, return to vendor, warehouse stores. Then comes execute and supply processes, and finally cross process visibility and exception management. So as I said, see, procure, produce, provide, product, perform, process, everything. So these are the 6 P's of supply chain. Now let's understand that what issues might come in a situation that I am just selling bananas from one place to another. So what comes in is that, let's say that I am trying to ship my product and there is a customer demand that I am trying to go ahead and, fulfill. So what happens is that in the customer demand, there would be a supply that I have to give. In order to match this supply and demand, I need to understand what is the warehouse, what is my warehouse capacity. So now coming back to the KPIs which deals with warehouse and inventory. Example, inventory days of supply. So historically, what used to happen is, managers have shown a strong preference for maintaining a minimal inventory. Because why? Because if you have too much of inventory, what happens is your, I would say the shelf, the product is not getting sold, sitting at the shelf. Okay, so you're not making any profit. Okay, so that's called how many inventory days of the supply. And inventory turnover. So inventory turnover is closely related to inventory days that I just spoke about. See, both metrics addresses the question of whether the company is able to maintain more inventory than it needs. Now, maintaining an inventory too high is a problem. Maintaining an inventory too low is a problem, and that's where it comes inventory forecasting. Lot of companies, we have seen that they have used standard deviation based and also mean based forecasting techniques, and that's where there are issues. I'll tell you, like back orders. I mean, if you are from supply chain, you'll understand what is a back order. Anyways, let me explain what is a back order. Let's say I have ordered this cup, and everybody is ordering. Sushi is ordering, Hiren is ordering, everybody is ordering cups. And now one of the listeners orders the cup and it says order stuck or it will be received after 45 days. What is happening at the background is it's in back order because there is no supply. The demand is there, but there is no supply. Now, how this happens is because there are various modeling techniques that you can use, but there are a couple of things that you need to understand. That there is something called intermittent demand that is there. Because of intermittent demand, this kind of situation happens. Okay, the intermittent demand is again divided into lumpy demand and all those things. So I think Sushri might plan to cover those. We will listen to them. But so that's called inventory turnover. Now, what happens is there are things called on-time delivery, which will be affected, as I was talking about. There will be on-time shipment, which will be affected, and supply chain cost as a percentage of sales. See, I will not be able to sell, isn't it? I will not be able to sell if I don't have an inventory. So if that happens, then it's a problem. Now think about this. Let's say there is a healthcare company who is selling drugs, medications, rather, in that way. Let me put it in a better way, medication. And the medications, there's something that you need to understand. It's called shelf life. What is shelf life? Let's say a cup will be on the shelf for how many days? Does this cup expire? No. But there is an expiration date to products like meat, product like vegetables, product like eggs. Then there is an expiration date for medicines also. So there is something called a longer shelf life and there is called a shorter shelf life. Now think about this, that shelf life for Bangalore and for Amsterdam. I'm selling a product in Bangalore as well as Amsterdam. Might be a different thing. Okay. The reason being there are a lot of things, government regulations are there. Because of that, there might be shelf life would be different. Can I have the same kind of shelf life for them? No. So what happens is that I need to maintain, and this is what the data scientists, they actually do. I need to predict that given a product, and we call it SKUs, it is there in the shelf, can I predict the shelf life? Or can I predict something called a shrinkage? Now this shrinkage is applicable for products which are of very low shelf life. Within one day it comes and goes. So FMCGs, CPGs, these kind of things that usually helpful. And Sushri has a code that she will run through. I'm just checking the time here. Okay, so that now few other aspects that we have in the supply chain is filling rate. So this is a very important metric because, as I said, how fast are you filling, and this is completely related to your demand and supply. Okay, then also I have perfect order rate. Now this metric is quite simple to understand. Although it sounds like a bit tricky, but it on a routine basis, simply because it incorporates a handful of variables related to process and delivery of the order of the customer. So briefly stating, what happens that the perfect order rate represents the percentage of order that can be delivered and fulfilled. Simple. Delivered and fulfilled. That's the order rate. So now all these metrics, what we do is we have a input data, then we have an output. These metrics are your target variables. This input data would be the data that you collect. Now, and you will see in a BI dashboard all these metrics. And what as a data scientist you do, not necessarily will model this, not necessarily, probably a data visualization, telling how is the distribution. That's probably what you would do. Then the data pipeline, data ingestion, pre-processing, denoising, and dimensionality reduction, all the pre-processing, and finally we try to predict these KPIs that I just spoke as of today. Now let's understand a little more that in terms of inventory, something called a purchasing inventory, storing inventory, profiting from the inventory. So raw materials or components that are brought daily to the warehouse, that is purchasing inventory. Storing inventory is raw materials that's moved into production facility to be made to finished goods. Now here is the thing, that let's say I am making a motor. Okay, my manufacturing company is making a motor. I will still have inventory. I am still part of the whole supply chain. Okay, I will still predict that, I will still forecast rather my inventory to know that when I will be out of some material, some parts. Okay, so that's one. And this manufacturing, if I talk about, that's a completely different ball game than if you talk about e-commerce, if you talk about retail. It's a different ball game altogether. And now the whole point is so that I can make profit. Now here is the thing, that one of the companies which I was working on, what they, as I was talking to you guys, that they were working on the inventory that they were managing, it was based on standard deviation and mean. So they were never able to meet the demand. Never. Either they were high on the storing, or they are low on selling. This is the major problem in terms, and still there are, you will still see companies that they face this kind of challenges. In order to come to a conclusion, what we usually, or what we have done in those days was, we asked that what data do you have? Now what we saw in this the day when they shared the data to us was that they had various stores. I was talking about Amsterdam and Bangalore, and they had similar. They have different stores with different selling patterns. Very difficult to model this kind of situations. Now you understand, this is a company, Amsterdam, Bangalore, somewhere in America. So there are various I would say buying and selling patterns. So how do I model this? There is something called a hierarchical, especially if I have to forecast, there's something called hierarchical forecasting. Now this is something where, when I am talking about, these are advanced AI and but analytics I will talk about. I'll not say AI. I think that's mostly used as a jargon these days, but these are most advanced analytics where I build a model. My model is able to go ahead and forecast, taking into consideration the hierarchies of one of the examples would be a state-based model. A state-based model will be able to give you. There are other hierarchical forecasting models when it comes to time series. Now, as I spoke about time series, let me tell you that, or I don't know if it's interactable. I don't think so, but is my data always a continuous data? When I talk about this forecasting, another question might come, what if I have discrete data? So there is something called a discrete time series, and there is something count data forecasting. Okay, now remember a thumb rule, a little bit on the thumb rule on the data, that if a data has less than 100, you should 100 data points, and if you're trying to forecast, treat that as a count data. You try to do a count data forecasting, and more than 100, you probably will find an autocorrelation more than 100 data. So that you can treat that as a time series. However, there are a lot of hypothesis testing that you need to do even before going ahead and treating as a time series. So basically, we always deal with data which is mostly or in terms of forecasting, mostly we deal with data which is in time series. And also understand this, there is something called when you forecast, what do we forecast? Shall I forecast for 2 years? Probably yes, we can forecast for 2 years, but how accurate it will be? Not really sure. Forecasting, the requirement that we have seen, people would want a daily forecast, a weekly forecast, a monthly forecast, a quarterly forecast. So that kind of forecast. Now understand something, there is something called a back forecasting. Okay, where I forecast back and see. I don't know if many people are aware of it, something called a back testing in algorithmic I would say trading. So there is something called a back testing also. Similar concept, but not exactly the same, but we do, there's something called a back testing. Also, let's say I am trying to find an anomalous behavior of my supply chain, okay, in terms of forecasting. I can do something called a predict and forecast. I predict the data and then I do anomaly detection on that. So rather, let me correct myself. I forecast the data, then I do an anomaly detection. So to be conscious of time, I will hand it over to Sushri, who will run you through a Jupyter notebook, which consists of lots of codes. And I think that is something very interesting. So Sushri, over to you.
Thank you, Indrajit. Thank you for highlighting the obviously just to have the background of this meeting and background of the use case that we will be presenting over here. So with that, let me just share my screen and then we'll go over the code, which is supposed to be interesting. Just let me know if you can see my screen.
Yeah, it's visible.
Cool. So as Indrajit mentioned, we will be going over the profit-driven demand forecasting for low shelf life SKUs, because as he mentioned, sometimes what happens for all of the companies, the bigger challenge is the, I would say rather overhead, is actually the inventory. So all the companies who are, even for the e-commerce, whoever are trying to sell and the vendor side, what they try to do is for the low shelf life SKUs, they try to get it out of their inventory so that new new products can come in, and there would be a balance between the customer need and the pricing and everything. So everything depends, or maybe they come up with the promotional deals in the e-commerce, let's say for Amazon and any of this e-commerce sites, they come up with the promotional deals, right? How do they come up with that? How do they understand that when it is going to be a hit, like the customers are actually going to go into a lot of purchasing spree and all of that, right? So we will be trying to see a 14-day forecast, like if I have to predict that what would be my sales or my revenue or my profit on the 14th day of starting from today. So in this section, we will be going over in the notebook, we will be going over the data preparation and feature engineering. Before that, obviously, I'll give you a brief idea about what is the data that is being used and how does it look like and how we can play with it, right? So next is the aggregation of transactional data into daily format. Why? This also will be coming into, because most, as Indrajit also mentioned, that most of the data are time series data, like it's time dependent. So, once you are predicting for a 14-day, like the 14th day, what would be your forecast of what would be the profit or what would be the revenue, that mainly depends on the time series. So it needs a bit of time series analysis, as long as as well as with the time series time series forecasting, we would also be trying to see that there should not be an anomalous. Why anomalous also should be minimalized? I would go over that in the respective sections. The next would be the implementation of a customer or custom profit loss type functions. There are a lot of different types of loss functions, right, that we kind of use in a day-to-day. I would not say analytics perspective, but from the AI or from the pure statistics perspective also, there are a lot of loss functions that we use, like MSE, RMSE and all of that. But once you use, or you are working on a client data, or let's say real world problem, that these loss functions do not always compatible, or they are not that compatible with what you are trying to forecast. So lot of data scientists, they come up with their own loss function just to meet the criteria, right? And the next would be the two-stage demand forecasting with Light GBM. As you can see over here, we have used Light GBM classification model or forecasting model over here. And also the next section, once is the hyperparameter tuning. Why hyperparameter tuning? In real world, no algorithm that you build or the model that you build, which is a basic model, fits into all the test cases. Like, in AI or ML, it's not a test case, right? It's not JUnit test. It's not that. It's more of like what the model fits or predicts or forecast on an unseen data. So that is where the basic model not usually go into production. We do hyperparameter tuning to get it fit with the trained data correctly so that it accurately predicts on test data. And I would also mark it down for you people, like, in real world problem, this is the biggest challenge. Like, it doesn't have to be 98% accuracy and fit, because normally what happens when you're achieving for a higher accuracy or you're trying to achieve a higher accuracy, sometimes what happens, the model overfits. So for the e-commerce, it's even a bigger issue, because you have to be accurate. You have to accurately predict for all of this, because their business depends on that. So I'll be going over all of these topics in this session. So as you can see, I have already noted down and have this notebook ready. Let's start. First step obviously is the data preparation. So real world data, let me tell you folks, it's not that clean that you deal with on the Kaggle or any of the data. You do a lot of data pre-processing, and most of the data scientist time actually goes into preparing the data which is modelable, which is suitable for modeling. So it is an extensively time consuming process. So in this section, we have three data, which is one is the item data, one is order data, one is info data. What is an item data? The item data is the item specific characteristics such as brand name, item ID, manufacturer, who and the selling price, all of these details, right? And orders is the purchase transaction. So over here we have taken the purchase transaction. What is a purchase transaction? So purchase transaction will include your order ID, your transactional details, your accurate time when you have purchased and what is the selling price, like what price did you pay for that product. So these are your orders data. Information CSB is nothing but the promotions, when the e-commerce come up with a promotional day or promotional date, and what would be the price. So promotional days, normally they go for a bit lesser price than the usual price, right? How do they come up with that? That all information is there. So first of all, we will import libraries that is needed, and then we'll get started. Over here, I have read all of these three data that I just spoke about into a pandas data frame. So my data frame looks like this. So this is the info data. Like I mentioned, in the info data, what would be there? It's like item ID, the simulation prices, the promotional days that is there. And in the item field, item data, we have item ID, brand, manufacturer. It's all related to item, like customer rating. What is the accurate rating the customer have already been rated for that product previously, right? What is the category? Which category does it fall under? And what is the recommended retail price? So for that product, is actually what is the recommended price? And later for the orders, it comes that what is the selling price? Exactly, for that product, what was the selling price? This date for a particular item ID, or an user or a customer has what was the price he had paid, right? So this is my data set that I'll be working on. So as you can see in the information and item, I have almost around 10,000 data points. And in the orders, I have almost 2 million, right? How is it 2 million orders? Because the time series data over a 60 days period also, you'll be having but like I would say in every minute somebody is buying something, right? So it's a very extensive and space consuming data, right? So I have taken a subset of the data that we have worked on. And so the next step, once the data comes, like I mentioned, it always pre-processing. So pre-processing, what do you do in the pre-processing? You go ahead and see what are the missing values present, what are the you try to draw the autocorrelation. You try to see that basically you make your data modelable. You make your data in a way that it can get into a model and predict and train on all of that, right? So first step, what I have done is I have merged this info and item data into one on the basis of item ID, because it's an inner join, because it's a primary key, right? So after doing that, my data looks like something like this, where I already have the category and recommended retail price from the item and info clubbed together, right? So next, let's see what are the data types. The first step, because these are the valuable things which you have to take care before getting into a modeling part, but because these are the ones, let me tell you, are going to throw you an error, because all the things have to be computational. Like model is algorithm is always something which does a mathematical computation. And once you mess with that beforehand in the data, when you're working on the data pre-processing step, it is going to throw you an error. And obviously it's a time consuming, and it's kind of a greedy algorithm, you go back, do that processing, go over to the next step, and it's continuous process. So you need to, like, data scientists often try to minimize those error counts from their experience, and they know that these are the things to be handled, right? So over here, I have already, so for this integer types, I have converted this integer types for brand, manufacturer into one object type, and why it will come into picture later in this session. So after that, as I mentioned, I need to know that what are my missing values. Like you can see, I have promotion. In the promotional, I have 8,600 rows vacant. Like it doesn't have anything on that, right? So I will be handling that later as well. So for first step is after this, all of these steps, let's do one thing. For the promotional, I mentioned that for each category, the e-commerce decides a promotional date, right? The deals date. So for those deals date, let's nest it out. So what do I mean by nest it out? It's kind of on one-hot encoding. I know this is not an interactive session, so when people go ahead with the categorical variables, they do a one-hot encoding, or they do a label encoding, right? So this is similar. The split nested feature doing a similar way, where that it is by mapping the category of the product into a promotion, like what category have been on which promotion has been done on which category. I'll show you that. Yeah. So let's hear, because promotional day is actually a date time format, right? It's a time or a day. So that's why this data type object has to be converted, right? So this has been done. After that, let's see that I'll club my categories all together just for the sake it will be used later. And I know from all of this section that I have 75 unique categories. That means that I have 75 types of product, right? That I have to sell. So these are my low SKU products. I need to predict or forecast rather that what would be my demand in the coming 14 days for this low shelf life products. Okay. So after the data preprocessing for the items have been done, let's go over to the orders, right? Because they combined together will be my feature or variable into the model. So for that, let's find out. This is more of a data or storytelling process where, you would be, it's kind of a story. You imagine characters. You need to know what it would mean, what would be my next step, like what would the character in my next step would do, right? It's something like that. Data science is all about that. So you need to know that how many orders actually have been there in my data, right? So I've just calculated how many orders have already been there in my data. And next, what I will do is I will try to find out that how many orders per day have been occurred. Like there are two ways, or I would rather say there are multiple ways, but my focus or motto over here is to predict or forecast a 14-day demand, right? So what I would do is when you work on this time series data, you can club it as a weekly basis, you can club it as a day basis, right? But what happens when you club it as a weekly basis, some of the data items you lose out on them. So you don't want to lose out on information when you're dealing with data. So that's why let's go over, for this purpose, let's go over and club it on a day basis. So how many orders per day, correct? Next, as I mentioned that what happens when you do all of it. So aggregated data for now have only the orders per day, correct? So what happens? This will result into your some missing information. What are those missing information? That you would know that most items that have been sold on few days, but those are some items are not sold on particular day, probably not been recorded, correct? But obviously everything is everybody in this world nowadays are after data, so obviously it will be recorded. But the next step is that there are few items that have never been sold before. You also need to have a demand forecasting for those particular orders, right? So let's go over and try to find out that how many orders that have never, like the orders that have been sold on a few days, but how many orders have not been sold on those few days. Let's try to find out that. Okay, just to have a balance out, data that you would also, it will not be skewed, it will not be skewed towards that, okay, these products have been skewed. Let's say for low shelf life, for example, bread is sold on a daily basis, right? But when you have a lot of bread data into your database, what happens is it becomes skewed. You don't want your data to be skewed for a particular modeling purpose, because it's gonna get overfitted, right? So let's also have products which has not been sold. So in this section, we are doing that. So after that, after the data has been prepared, what the next step is, we need to have labeling promotions, right? Because as I mentioned, promotions are the deals, the e-commerce section, e-commerce players, they try to find out, like they try to dig in to kind of have their sales or revenues generated, right? So these, when you manually mark the so in this data, what happens is there are two types of data, right? One which is already been labeled and one which is not been labeled. So for sometimes what happens in the real-time scenario, data are not labeled and you need to do that manually. So manually to do, putting into a label means that you need to know that which day I'm going to do a promotion, right? So to include that, like what is my pricing and what is my promotional orders have been incorporated, that manual effort have been done here, so that I'll have a one data which would have everything, correct? After that, what is my next step? I'll be trying to find the promotional days. For the promotional days, also my next step would be to create a pattern or create a feature set. As you can see that all of this data has very low feature, right? Just 10 columns or probably less than that. But real world problems, you cannot have a forecasting model just with the 10 columns. You need to have a feature engineering in process to find out features. Sometimes features are also derived features. These features have to be calculated on basis of 2-3 columns combined or some type of mathematical operation, or also you can go ahead and do a feature engineering on them just to have a feature extraction technique, right? So these are also my upcoming, if there in the session, we'll be covering that part. So first, I will be trying to, as also Indrajit mentioned, right, when some companies do that, they calculate the promotions on the basis of median or mean or standard deviation, but they can't, they're not being able to accurately predict or forecast the demand, because there are nowadays the advancement of this analytics is so much that this is not just restricted to statistical models or just very parametric methods. It has gone beyond that. It has become a very well-known competition for companies to predict that accurately. So first, I was trying to, I'm showing you over here the same things, that how companies try to draw that, but also on the basis of, I'm just giving you a comparison kind of stuff. So next step is for us to compute, like once our promotional days have been marked and we already have the orders in place, let's try to figure it out. And everything has to be visualized. It's not just 1 + 1 = 2. You need to visualize it on the graph for your, obviously for your fellow data scientists to understand, for somebody who is a customer also to understand, right? What you are seeing over here is actually your day versus total order. That means that in a day, how many orders have been placed. Why this happens? This yellow dot or yellow ones are actually my promotional days or my promotions marked, which is there. So, but also you can see there are this purple right? These perplexed ones, normally what happens sometimes when you are trying to put in there is manual effort, what happens is you tend to have a outlier because it's a manual process. Somebody maybe types in something wrong, which becomes a outlier. So as a data scientist, you need to understand also that you need to identify the outliers before getting into a modeling part. So the promotional over here, there are some outliers as promos, but misses a few points that are less prominent like this, right? But the promotions doesn't mean that that a lot of orders have been coming. Let's say large number of orders doesn't entirely mean that we have a promotion event or deal going on, right? It could be for some other reason also. It could be for the reason that the customer has this need and they're just buying it. It's not just because of the price drop, correct? So these type of scenarios are kind of considered as your outlier, where you don't have a promotion, but a lot of orders are coming in, correct? So next step, when you have, like I mentioned, is the feature engineering, right? So feature engineering, now that when my data has been aggregated, what we do is we do a feature engineering on what my target. My target is what? That 14-day demand forecast, right? So we will be doing, for this case, what I have done is I have extracted the data on the based of days, like 1st, 7th, 12th, 14th, and so on. And then on top of that, my target data is, or the target day is 14th, correct? And for each item, or for each of these items, I need to calculate that what is my total count of orders and order items, what is my total count of promotions, what is the mean item price for that, and recency of the last order. What is the recency of the last order? That means that how frequent or what was the last time that order has been placed, not just by one user, by different users. They club that, they club that into one. They try to draw inference out of it. Also, the next step would be to calculate that orders and promotions, but with respect to my manufacturer and category level. Why? Because I need to know that for one category, how many orders are coming in. Also, for a particular manufacturer, how many orders are coming in. Because once you go into an Amazon, you can see for a product, there would be different sellers, right? It's not just Amazon owns some vendor. It's also some different vendors who are selling the same product, probably at a separate or different price, right? So these all have to be mapped. These all have to be taken into consideration before doing a feature engineering. So first I will calculate all of that, and after that I'll use the TS Fresh package. It's a package which automatically extracts the feature engineering or features out of my orders, or over here it's an order dynamic, right? So out of the orders. So what we'll do is the TS Fresh does is it calculates more than hundreds of features, but in a time series or in any real world scenario, you don't want to take into account the missing values, or for the 100 features, it should have some value. It's not like that 100 features have been drawn, but some of them are actually empty, right? So it needs to be fulfilled. So let's go ahead and do that. The parameters, as I mentioned, for the target days, my target is 14 day, and first I will calculate what I said, the total count and total order items. So over here, first time what I'm doing is I'm aggregating with respect to the item ID and manufacturer, like I mentioned, right? For each order, I need to know that for each category, what is my order, and for each manufacturer also, what is my order. So these clubbing have been done, and after that, I'll be calculating these scenarios that I have mentioned here, like total count of promotion, mean item price, and all of that. This has been done in this piece of code. I know it's a long piece of code, and all of that have been sold or stored into a particular into my particular data frame, right? So final preparation, and as I mentioned in the last slide, I need to have the feature engineering, but also I need to get the features which are not zero. I cannot go for the zero features, right? In this section, I'm actually calculating the feature extraction out of the TS Press, and over here I'm removing the missing values and computing the mean price of the for the mean price or the ratio of the manufacturer and category, all of this into an order file or order data frame, right? So over here, the feature extraction is taking place. And after that, I can see that over here, the feature extraction has outputted 470 features. I just had 10 features, right? How did it come up with the 470 features? So as I mentioned, the 4 extra features are actually derived features. The derived features which an algorithm thinks by drawing some mathematical combination or mathematical computation between the features in that data, right? So now let's create an item data set. We have already created the item data set and stored it, right? Where we have calculated. Let's just try to see what is my data. So for the ratio, first of all, let's try to see what is my actual to recommended price, which have been calculated here, and I'll store it as a recommended simulation price, right? Next, what is my ratio item category index, right? For the categories that I had, what is my category? So I've clubbed them all together. Next is my customer rating ratio per manufacturer. Also, that have been stored, like what is the rating for the customer, because all of this, customer rating for the manufacturer, what is the customer rating for the product, for category, all of this are very essential to draw any kind of forecasting things, right? So after the features have already been created, we have come up with the data, which is now ready to get into a model, right? So first, my data preparation has been done, my feature extraction has been done, my data is enhanced to a level where it is like information have not been lost, but rather I have informations in a latent space, which is exactly as a feature, like feature in terms of features, right? So after the data has been prepared before modeling, what we do is we try to calculate the we draw a subset or random sampling of getting a training and testing set, right? In real world, there is an additional step which is called a validation step, where we do the subset from the training set, which acts as a validation set. What we do is during the training itself, when we are calculating the loss, we are also doing a validation on a subset of the training set. So let's say in this approach, I have done actually 7-fold cross validation. What is a cross validation? So cross validation is in a training, let's say I have 100 rows. What I will do is I'll do a batch or random sample. Let's say in one batch, I'll have 10 of samples for 10 clubs. Okay, so for all of this 10, I will pick out randomly that 2 instances will be or 2 data records will be my validation. So what will happen on this 8 data, data rows, my model will train. But in each of this step, it is also will test on the random 2 data that it will generate, right? Or in the it will subset from the training, and it will try to minimize that loss in the next step. That is my step-by-step approach, right? That is my validation set 1. What is a number of folds? So number of folds is exactly that how many folds you want to draw out of the training. Like how many, it's kind of a batch size. Like let's say in one batch I have 10, but let's say I have 100 data and I want to, my cross validation is, let's say 10 folds. So my entire 100 data will get clubbed into a sample of 10 each. And out of this 10 times will, or 2 times, or whatever the specific amount of time, we will be validating the loss or maybe minimizing the loss, right? So that will be my approach. Over here, what the training and testing has been done, but my demand forecasting also has a promotional, like we will be doing the future promotional per manufacturer. We will be doing a promotion for categories. These are the future forecasting stuff, or the kind of target that somebody like the company or the e-commerce is trying to achieve. So after my training and testing part is done, what I will do is, so let me just remind you that the training and the testing has it happens on the go, but the training and validation, it happens while during training, like on the fly. Okay, so you what we do is we specify the number of folds and it does the validation during the training. So let's go to the modeling part. So what will happen in the modeling first? First, I had mentioned, right, there is a custom loss function. So real world problems don't just define on the MSc or calculating the RMSc or improving the accuracy. These are not my target. My target is to have a profit. To have a profit, at the same time, I should have also a loss, which would be a loss function, which would be high or increasing my profit based on my orders or my revenue, right? So what are these? So profit function of the retailer, because somebody who is selling that, they should get the profit, right? Not as an e-commerce. So the function accounts for, so this custom loss function that we have defined is called as a profit function. What is a profit function? What we are trying to do, I'll also tell you why profit function is needed. Let's say sometimes predicting, like let's say over predicting a demand also incurs with a fee. What is a fee? That fee is actually the infrastructure. That fee is the overhead of the inventory that comes. Let's say there is a demand. You have forecasted that there is going to be a demand for a high selling price product, but that demand has not been met, but you are already filled up your inventory. There is no space for other products to come in, even if those are the low selling price products, that those would not be possible to get into your inventory because your inventory is already over it, right? So for this product, sometimes over predicting the demand comes with a fee, right? So we need to minimize that as well. Or, that would be that inventory price. Normally people think that, you're selling and you're selling at a X amount of price. So your profit should be that what is the incurred kind of USP and what is the what is the selling price, and the minus of that is the profit. It's not. In the e-commerce, it comes with obviously the revenue, but there is another cost which is called a inventory cost. You need to that inventory cost sometimes is pretty high for low selling SKUs is pretty higher even, because these are the ones which take up inventory. These are sometimes ice cream. It takes up inventory for the to store it, the cooling price and all of that. These are this kind of overhead gets deducted from your profit, from your revenue itself, right? So let's conduct a custom loss function. So this is a custom loss function, profit function, as I mentioned. So what I do is I calculate the sold units. My sold units is straight away that how many units have been purchased by a customer or any customer for that matter. Next is the overstock unit. What is the overstock unit? So my overstock unit is actually the unit that have been there in the inventory for a while. That is my that is something which is going to bring down my profit, right? And my profit would be my revenue. Revenue which is obviously the units sold, how many units have been sold and at what price. And my fee would be that for those overstock units, what is the price I'm paying for that per overstock units? That is my inventory cost, right? So that gets minus, or that gets deducted from my revenue, and that is my actual profit in an e-commerce section, or for low shelf life SKUs. That's a bigger issue. So so what will happen is this custom function will get trained on my data, but where it will try to increase my profit, right? It will try to increase my profit, fit it on the data. That will be in each step, it will try to increase my profit. That's how the model learns. Let's go over to the model. So what will happen is I have chosen light GBM over here, but like selecting a model is actually not a task where you go ahead and just choose any model. You obviously do a lot of stuff. It's a hit and trial method. Like sometimes some models work, sometimes some models don't work, right? So that's why we have done a lot of kind of hit and trial method, and that's how we have come up with a light GBM model, which has performed better comparative to other models. So light GBM, in the light GBM, when you are trying to actually put in the custom loss function, there are two stuff. One is it tries to calculate two stuff. One is my residual, and the next one is my mesh-in. So these two are kind of first degree and second degree derivatives into my model. as I told you, model is algorithm. Algorithm is equal to a mathematical operation. That's how it calculates. So I am trying to compute those two over here, residual and like gradient and Hess. So after that, my modeling pipeline. So what will be my modeling pipeline look like? It will go into my model, will be trained. First, my model will be instantiated. That object will get trained on my data. So over here, you can see there are some different parameters, right? So the parameters which are actually hyperparameters of the light medium that I have defined over here. And I am specifying some of the models. Like over here, the scores are all of this. It's like if you want to train it on a parallelogram, so or parallel cluster method, right? So these have to be defined. And then once the model has been instantiated, I will train it on. So so I mentioned, right, that I have done a 7-fold cross validation here. So the cross that has been specified and the model has been trained. Once my model has been trained, let's see what is my accuracy, or let's say the profit, and what is my RMSE. Just for the public demand, I'll just also calculate RMSE. Let's do that. So you can see for my so my average RMSE on the test set, which is unseen data, has come up as 69.66, whereas my profit is pretty high. It's 54.19% for a business. For a business, if I myself is running a business, 54% profit is pretty damn good actually. So let's say if I'm not even convinced, some customers are not convinced that they want to higher the profit, right? So what happens is the modeling technique, we call it a hyperparameter tuning. So we do the hyperparameter. I have shown you the hyperparameters above, right? So we will be doing that hyperparameter tuning again. Before that, I'll come back to this, but let's just see the hyperparameters. So these are the hyperparameters that manually, or not manually, I would say, but have been chosen. And also at the same time, I have tried to draw that what is my accurate, or what is my higher profit reason hyperparameters that have been drawn. I can do that from a model. Okay, so I'll be able to show you that. Just give me a minute. Yeah. So this is my best parameters. What is my best parameter? That in all of these parameters combined, my model has performed the best, and my model has the highest profit, and also the minimized RMS. Okay. So let's go back to the chart that I have shown you, or the graph, I would say. This is my residual plot. Residual plot is showing you the predicted demand versus the actual demand. You can see the scatter plot that it is predicting it, or the forecasting is currently happening at a better go. But these areas have not been included. Why? Because there is a scope of improvement. That's how I went into a hyperparameter tuning, right? Because these areas have not been ventured. So it can be predict the most. The next step, the next graph that I'm showing is the feature importance. So what is the feature importance? I did not have all of these features. Did I have? I did not have in the original data, right? These are my features which have come up from the feature technique or the feature extraction. You can see that which all features have been more significant in plotting or in giving you the best result. So in the next step, what happens is we go ahead and select the features which have the highest significance to my forecasting. Rather than taking a insignificant feature, I should go for a significant, let's say, lot of features, and in order to predict the forecast the demand correctly, right? In this case. So this is all in all the notebook, and what are the steps, and what is my accuracy, and all of that. Once the model has been done, what happens is we store that model, and that model gets used in the deployment. And once the new request comes, once a new data or unseen data comes, we try to draw the inference only on the model file. Sometimes these model files are a bit heavier because you are dealing with a lot of data, and the models are also very heavy. But sometimes it's very similar, but very smaller in size. So this pickle files. So once it is an iterative process. Let's say I have a baseline model, then I kind of build on top of that, right? So these models get replaced in the deployment sector or the deployment infrastructure. It gets replaced, and we do deploy the most accurate results. And in this case, which is the higher profit, also the correct accurate of the demand forecasting. So that's all about the full like what is the data like data science thing happens, or what is the advanced analytics methods that we do once we get the data and all of the processes that I've mentioned. Yeah, I'll be taking any questions if you have.
Yeah, so just wanted to add to this. See, what we have done is, if it was a real data, it is not a real data. I mean, it is there in the open source market and in the internet, you guys probably can find, but the data altogether. See, we did this project almost 3-4 years back. I think a couple of things that I wanted to point out is that there are issues when we usually do this kind of projects. What are the issues? Numerous zero values. Okay, and there are numerous zero values. Why? Because see, one thing that I wanted to tell you, that there is something called the intermittent demand. Okay, as I was talking about, right, the demand is divided into various. One, what Sushi probably showed is very smooth, well-structured data, but there are others. Intermittent demands, lumpy demands, erratic demands. And there where you will see that there are zero values. So if you have so many zero values, don't just remove all the zero values. You are losing the pattern. If you give out those zero values, you are actually going ahead and losing the pattern in the data. So you might ask, what needs to be done in that scenario? So there are a couple of models that I will tell you, which are called zero inflated Poisson autoregressive models, zero inflated negative binomial autoregression, dynamic zero inflated model. Okay, so and zero inflated time series model. Now, I asked this question in one of the interviews, that what do you do when you get lots of zeros in your forecasting? I got the answer, I just remove the zeros. So that's not correct. That should not be done. And this there is a particular method. I don't know if you guys are aware of it, but Google it up. See, everything is available in Google. You can just go and everything is available in Google. We are not telling anything which is not there in Google. So there is something called a Croston's model. So you can go and visit that. There is the models. There are other models like, if I can recall, there's something called Dharma. There is called Anarma. So these are similar to that Arima, that kind of model. So these kind of models we usually use for forecasting. And when you just get a demand problem, in a demand and forecasting problem, don't just think that it will be a smooth. Don't just think about it will not be smooth. Smooth is very easy because you have to tackle a lot of problems. And the project, if I talk about the project, this kind of project usually takes 4 to 8 months, depending on the complexity. Like when I say complexity, depending on the hierarchy, if there are any hierarchy in the data, depending on what types of forecasting are we trying to do, and how, as I said, how to control the zeros in my data. Then I can also do something called a severity and a complexity. Okay, that modeling can also be done. And so, I mean, what I'm trying to say is that this is a topic by itself, especially in supply chain area or any area as such. This is a field by itself, rather, and most of the time you will be spending time in just visualizing and analyzing the data, and that's take most of the time. And then what Sushi just explained is quite niche. You will not even get time to do that if you are in a real world scenario, because not everybody does modeling in terms of when it comes to AI/ML. There are a lot of BI that's happening, KPIs that's happening. When I say KPI happening, in the sense people trying to visualize the KPI. So the first thing that you should do being a data scientist, and if you're learning, if you're new to it, is as and when a problem comes, Google it. Go to Google, see what other people have done. You will get lots of ideas. Read research papers. Read research where what is happening in the real world. What are the innovations that coming in? In time series, we can use graphs to predict. There is a temporal convolution network, TCNs, we can use it. So she could have gone on with the modeling, she could have gone on and on and on. There is no stop in modeling. But as she was talking about, which I really like, is what is the business problem that you are trying to solve? So the takeaway should not be the codes. The takeaway is the business problem that we just described. And this is a real world problem. This is a real world problem. I think 60 to 70% of the time as a data scientist, you will try to solve this. Just by solving forecasting, you can get a very good salary. Trust me, in data science. So anyways, we'll stop here and we'll see if there are questions.
Yeah. So I just saw a question from Miss Priyanka. So she's from FMCG supply chain background, and she usually works with SAP PP and MM modules and MS Excel for planning and inventory management. How does data science help someone like her who has almost no coding experience?
Don't worry, you don't always need data coding experience for data science. Yeah, that's you don't need. You can do it in Excel. The first thing that we do in any company that we go is, let's say a time series data. We take the time series data into an Excel, and we try to see. Don't model on Excel. You can model on Excel also. Excel is very powerful. What do you think? Have we all started with Python or started with R? No, we have also started with Excel. Everybody starts with Excel. There are data scientists who can just do advanced Excel and give you results which are more powerful than a model. So that's how you can. There are Excels for data science. I think there is a book also somebody has written how to use Excel in doing data science and machine learning. So when I say machine learning, it's not advanced, but basic machine learning definitely can be done.
And just to add to Indrajit's point also, people think that coding is a big stuff, or sometimes they won't be able to understand or they won't be able to do it. But trust me, Python is very easy to learn, very easy to understand. And when you are talking about Excel, even Indrajit said, right, everything can be also done in Excel. Just the point is the time. If you have, the processing time takes a lot of time, which can be, kind of taken down to an enormous amount when you are dealing with coding, because there you have a provision to get into a GPU, to get into, and now it has come to a TPU, right? But that gets kind of overhead in terms of Excel. But trust me, Python is very easy to learn and everybody can learn it. And it just needs a one step at a time. It might get overwhelmed at the first, but it is very easy to learn.
Absolutely. Thanks for the input there. So one more question that I just saw, just a second. Yeah. So so it's just about how a SCM person can get into data science. So you just explained about that, like for Python, Python is one of the easiest languages right now. So one question is asked that do we have to try out different models to find out which suits our project best?
Yes, that is always the case. Even I had mentioned it's always a hit and trial. Nobody would be telling you that this is a model, try it out and it's going to happen. Nobody knows that. It comes with practice. It comes even for Indrajit also. He can say that it comes with his experience. It comes with my experience by doing a lot of similar stuff. Once you talk about, a model, not everything is a mathematical operation, right? So for that, even that linear regression sometimes fits into a lot of real world problems, which gets where people try to use neural networks or a lot of very heavy models. So yes, like I mentioned, it's all about trying to hit and trial so that you get a perspective of, okay, my data is this, then probably this model will come into picture. Indrajit, you can add into this, but I know even for you also it's always.
Absolutely, Sushri. I couldn't agree more. I mean, start small. Start small, basically very small. If it's a time series, probably do smoothing and try very small. Okay, that's how. If it's a non-time series data, do a regression. And see, you might get fantastic results. You don't take, I think I saw someone taking a saw and cutting a biscuit. You don't want to do that.
Yeah.
You do not want to do that. And yeah, that's all.
Okay, so last question for the day. Just saying, yeah. How do you approach building a localized time series model for sparse seasonal demand?
Cool. So there is something called a seasonal ARIMA. Okay.
Yeah.
If you use ARIMA.
Yeah.
Right. So I think that's a very good question, and probably if we have more time, we can talk a lot about it. But that's at that point for this session. That's how I will stop.
Yeah.
There are other things.
Okay. Yeah. So final thing. Can we just get a copy of the case study that that was taught now?
Absolutely. Yeah. I'll send it over.
Okay, great.
Yes.
Okay, so that will be uploaded and shared. So thank you both of you for joining today and giving some good insights on inventory management. So the case study actually gave a good insight on how to like basically using the customized loss function, right? So how to calculate the profit and use that as a cost. So also I would like to thank the audience for joining us today and make this session more interesting. So this is where we'll be stopping today. And before I go, I would just like to announce to our audience that we have another session tomorrow, the second session for Data Science Speaker Summit. And since everyone was talking, since Indrajit mentioned that Excel is a very powerful tool, our next speaker will actually showcase a small example of how Excel can be used for machine learning. Basically example of small regression machine learning. So make sure you join us tomorrow as well. So that's all for today, and we'll see you tomorrow. Good night.
Thank you. Good night.
Thank you very much.
Good night.
Good night.